This is the forming, dedusting and loading robot created by Automation Solutions as a part of their work for RevMedX's wound stabilizing mini sponge project. This machine works last in the process of manufacturing these mini sponges. We've covered the thread winding robot, the first stage of this process, in another video, which you can find in the card in the top right or in the video description. In that video, we discuss the mini sponges in greater detail, as well as cover how the first stage of manufacturing them plays out with the help of the thread winding robot. So what does the forming, dedusting and loading robot do? Well, after the sponge has been laminated to the frame wound by the thread winding robot, as well as compressed and adhered to the thread, this machine uses a servo actuated punch to form each 10mm mini sponge. This is the forming stage. The punch travels along a 2-axis track to align with each thread intersection before punching. This creates that X shape on each sponge. This punching stage can sometimes generate small particles that end up on the sponge. In order to remove those small particles, each sponge is pneumatically transferred to the next stage. This next stage is called the dedusting stage. Each sponge, after being formed, is moved to a turret called the deduster. On the base of the turret is a screen just large enough for the small dust particles to fall through. A vacuum is positioned underneath the screen to further pull through any of these dust particles. At the top, air jets blast the sponge to ensure nothing is left behind. Each sponge is dropped into a slot of the turret and is jostled as the turret rotates, while the air beneath is pulled through the vacuum. After a full rotation, a servo-actuated vacuum tube uses machine vision to locate each sponge, picks them up, and delivers them to the final applicator, where they are stacked neatly into a tube. The tubes, after being filled, are assembled with an applicator cap with an opening just large enough for the sponges to exit, and a plunger-like mechanism at the back for the user to push the sponges through the cap and into a wound. This process proved to be a complicated task to automate, and there were plenty of hurdles to overcome for the engineers. Maintaining accuracy and consistency was a challenge with the amount of moving parts and fragility of the material of the sponges. It was imperative that each sponge was uniform as well as clear of debris. To ensure this, the engineers had to fine-tune the punching mechanism to maintain clean edges on each sponge, as well as invent a dedusting mechanism that didn't disintegrate the sponges or cause them to lose form. To help ensure the uniformity of the product, the engineers included an onboard automatic sponge testing mechanism, which will be covered in our final video on the topic. In the end, despite the complex challenges faced, the engineers at Automation Solutions had successfully created a machine to efficiently and accurately create, refine, test, and load these medical mini sponges for use on the battlefield.